Okay, let's look at the worksheet for chapter 6. Now, you see that the worksheet is for 6.1 through 6.4. On exam 3, we just cover 6.1 and 6.2, so we'll just give this a look, and I'm gonna do most of the problems, and we'll just go from there. Now, in this one, we see we're asked to find trig function values of angles that are in degrees. Well, remember the conversion factor. One trip around in degrees is 360. And then one trip around in radians is 2 pi radians. So we get a conversion factor if we divide by 360. That means we have a conversion factor of pi over 180. So if you're going to convert from degrees to radians, if you wish to do that, you would multiply the degrees by pi times 180. For example, 225 degrees, we just put 225 degrees here. And the unit degrees cancel. And just remember, the way to use this conversion factor, see, this is 1. The way to use this conversion factor is the denominator is what you're going to end up with. So if you want to end up with radians, you want the pi in the top. If you're converting radians to degrees, then you want the degrees on top. So just flip this over. So what are we going to get here? Well, this is 180 and that's 225. And we just need to reduce this. This is going to be 225 degrees divided by 180 degrees times pi. Now, what's this going to be? Well, let's figure this out. We can obviously divide both by 5. So if I do that, 5 will go into 225 45 times. So if I divide by 5, this is 45 pi. And if I divide this by 5, I get 36. Okay, well that means then we can then further cancel by 9 and we get 5 pi over 4. So 225 degrees is 5 pi over 4. And that's what you want to do if you want to convert these. But see, I'm not going to do that. If I want the cosine of 225, I know the trig function values for 30 degrees, which is pi over 6, 45 degrees, which is pi over 4, and 60 degrees, which is pi over 3. So all of these that you see here in this problem are going to be multiples of those guys. So just like we did in radians, I'm going to figure out where 225 is. And it isn't hard because here's 0, halfway around is 180, right? So let's do this. This is 90 degrees, 180 degrees, 270 degrees, and then back around to 360. And then if we keep going, we'll add 90 to 360 and get 450. 450, if we add 90 to that, we'll get 540, etc. So where is 225? Well, here's 270, here's 180, so it's in this quadrant. So the reference angle is going to be, this is going to be equal to the cosine. The reference angle is going to be 225 minus 180. So that's going to be the cosine of 45 degrees. The reference angle is 45. Now, what are the cosines in quadrant 3? Well, they're negative. And of course, the cosine of 45 is square root of 2 over 2, so it's a minus square root of 2 over 2. The technique we used when we evaluated trig functions at multiples of pi over 6, pi over 4, and pi over 3, it's going to be the same technique and it's going to work just as well, except I think it's harder because you're using degrees. And when we have multiples of pi over 6, pi over 4, and pi over 3, we know instantly what the reference angle is. It's going to be, if there's a 3 in the bottom, doesn't matter what's in the top, The reference angle is pi over 3. So let's continue. I want the cosine of 300. Well, let's go over here. Here's 270, and here's 360. So 300 is in quadrant 4. So now this is 300. The reference angle is going to be 360 minus 300. So this is going to be equal to the cosecant of 60 degrees. And we're in quadrant 4 now. Remember, cosecant is just 1 over sine, and the signs are negative in quadrant 4. So this is going to be a minus 1 over the sine of 60. So this is a minus 1 over square root of 3 over 2. So it's a negative 2 over the square root of 3. And if you rationalize that, it's negative 2 square root of 3 over 3. Okay, let's get down to number 4. We want the secant of 660. Where is 660? Well, it's bigger than 360, so all the way around is 360. And if we add another 90 to 360, we get 450. Add 90 to that, we get 540. 540. Add 90 to that, we get 630. So this is 630. And this is going to be 720, right? So 660 is down here. So this will equal, now this is 660. The reference angle is the difference between 720 and 660. So this is equal to the secant of 60 degrees. And remember, the secant's a cosine, and the cosines are positive. So this is going to be 1 over the cosine of 60. So it's 1 over 2, or just 2. So it's just the same process that we did with radians, except with degrees. Okay, now look at number 5. If we're given that the secant of some angle is 9 and the terminal side is in quadrant 4, find the other 5 trig function values. Well, we draw a unit circle and we just write down what we're given. We're told it's in quadrant 4. So what I'm going to do is use this angle, which would be the reference angle. Now we're told the secant is 9. That means then, well, what is the secant? The secant's 1 over cosine. So therefore, the cosine of theta is 1/9. Now, what does that mean if the cosine is 1/9? Well, cosine is, remember, the adjacent over the hypotenuse. So the x value along the x-axis is 1, and the hypotenuse is 9. I need to find this missing side. So let's just label it question mark for the moment. So by the Pythagorean theorem, I have 1 squared plus the question mark squared has got to equal 9 squared, right? This is a leg squared, hypotenuse squared. So I get question mark squared has to be 80. 9 squared is 81, subtract 1. Now 80 is 16 times 5. So the question mark has got to be 4 square root of 5. But look at this. This is in quadrant 4, and this side is going to be negative because it's below the x-axis. So this side is a negative 4 square root of 5. And see, now I'm done. So if the secant is 9, then we know that the cosine is 1/9. This is reciprocal. Now what's going to be the sine of the angle? The side of the angle is the side opposite over the hypotenuse. So this is a negative 4 square root of 5 over 9. So I've got the sine, I've got the cosine, tangent. we just read off. Tangent is what? Opposite over adjacent. So it's a -4 square root of 5 over 1. Cotangent. See, once I get this, to get the cotangent, I take the reciprocal, -1 over 4 square root of 5. So we rationalize this thing, and we get that the cotangent of the angle is going to be square root of 5 over 20 minus. And is that it? No, we need the cosecant. Cosecant's going to be 1 over the sine, so that's a -9 over 4 square root of 5. So that's going to be a -9 square root of 5 over 20. So the key is getting all 3 sides of the triangle, and once you get that, you're home free. Now, I don't know what to do about this. It says find x, but I don't see anything but blank triangles. So maybe I'll try to find a different copy, but I don't see anything. Let's go on down to number 7. A 20-foot ladder leans against the building so that the angle between the ground and the ladder is 60. So here's our building. Here's the ground. We've got a ladder leaning, and we're told that this is 60 degrees. Cool. Now we're also told that the ladder is 20 feet. So this is 20 feet. How high does the ladder reach the building? So we want this side. So look at this. Let's do part A here. I want how high the ladder goes up the building under these conditions. And we're given the angle. We want the side opposite. And we're given the hypotenuse. So that indicates we use the sine function. So we say that the sine of 60 is equal to the distance up the wall divided by 20. Now, the sine of 60 is square root of 3 over 2. So that is equal to the question mark over 20. And now just cross multiply. So we get 20 square root of 3 is equal to 2 times the question mark. Divide by 2, and the question mark is equal to 10 square root of 3. And that's the answer. Now for part B, what's it going to be if the angle's 72 degrees? Well, 72 degrees is not one of those that we know. But if the angle goes up to 72, then it's going to reach higher up the building. So I'm going to do the same thing, but I'm going to put sine of 72 here. So the sine of 72 is equal to the new height on the wall divided by 20. So that means then that this is going to equal 20 sine of 72 degrees. And I don't know what the sine of 72 is. Let's see. If I turn on a calculator here, do I have it set up in? No, I've got it set up in radians. So, okay, if I just use a calculator then, and if I just go 20 sine 72, and I'll get that that's about 19.02113033 feet. Now, does that make sense? Well, our previous answer was 10 square root of 3. So our previous answer was about 17.3, so it makes sense. Just think, if you're at 60 degrees and raise it up to 72, you're going to go higher up the wall. Okay, well, part B is not very good because we don't know what 72, we don't know the trig function values for 72 is. Okay, let's look at the second page of this. So it's another word problem. From the top of a 200-foot lighthouse, the angle of depression to a ship in the ocean is 30 degrees. How far is the ship from the base of the lighthouse? Well, okay, here's the ocean. Here's the lighthouse. This is 200 feet. And out here is the boat. And we're told that the angle of depression is 30 degrees. Now, what's the angle of depression? Well, draw a line parallel to the ocean. This is the angle of depression, or some books call it the angle of declination. So this is 30 degrees. Now, that means this has to be 30 degrees by alternate interior angles or something like that from geometry. So what is it we need to know? We need to know this dimension. This is what we need to know. So we know the side opposite. We know the side opposite, and we want the side adjacent. That means I want to use tangent or cotangent. I'm going to use tangent. Okay? I'm going to use tangent. So we have the tangent of 30 degrees is equal to 200, and let's call that distance L, right? Tangent's opposite over adjacent. So now I need to find out L, so I'm going to cross multiply, and that gives me L is equal to 200 over the tangent of 30 degrees. So, okay, now my job is to find the tangent of 30 degrees. Well, that's going to be the sine of 30 over the cosine of 30. And these I know. The cosine of 30 is 1/2, and the cosine is square root of 3 over 2. So this comes out to be 1 over the square root of 3. Now, I'm not going to rationalize it. So this is going to be 200 divided by 1 over the square root of 3. So this is 200 times the square root of 3. That's how far away the ship is. So part B, how far is the ship away if it's 25 degrees is the angle of declination? Well, let's think about it. If I drop this 30 degrees, I'm here, and if I drop it 20, it's going to be further away. So what we'll do here, if we just replace the 30 degrees with 25, we'll get that L is equal to 200 divided by the tangent of 25 degrees. Now, I don't know what the tangent of 25 is. And we're not permitted calculators, so I don't get the point of this, but it's going to be 200 divided by the tangent of 25, and that gives me about 428.9013841 feet. And see, that makes difference. That it's going to be further away. If we go 200 times the square root of 3, we get about 346. This is about 346. This is 428, and that makes perfect sense. Now it says find the area of a triangle where the sides are 15 centimeters and 10 centimeters, and the included angle is 30. Now, we don't know anything about this triangle. This is a funny one, isn't it? We don't know anything about this triangle. Is it a right triangle? Well, I don't know. It doesn't say, does it? So here's what I'm going to do. It's wrong to assume it's a right triangle. So maybe it's this triangle. I don't know. This is going to be 10, and let's say this is 15. So we want to find the area of this. Now it says if the included angle is 30 degrees. Well, that's the included angle. Well, think about it. That can't be right. That is not 30 degrees. Right here would be 90. So that's not a good picture. Let's try it again. What it's got to be is something like this, isn't it? This would be 30 degrees. See, my picture didn't make sense. Let's say this is the 10 and this is the 15, and we want to find the area. Well, now, one way to do this is to find this side here, because we know that the area of a triangle is 1/2 the base times the height, right? Okay, now that's the height. The base is 10. So let's think a minute now. What I want is the side opposite the angle, so I would have the sine of 30 is equal to h over 15. So h is equal to 15 sine of 30. Y'all see that? Well, that's kind of cool because that's 15 over 2. Because the sine of 30 is 1/2. So therefore my area is going to be 1/2 the base, which is 10, times the height, which is 15 over 2. 1/2 of 10 is 5. So this is 75 over 2. And that would be centimeters, wouldn't it? Centimeters squared, right? Because this is centimeters and this is centimeters. So it's 75 over 2 square centimeters. Okay, 10, 11, and 12 are just fun. Here's what I'm going to do. I'm going to do all these the same way. I'm going to let A equal what's inside here. I'm going to let A equal the inverse sine of 2 over 7. See that? Now, as soon as I do this, the original problem becomes the tangent of A. Y'all follow me? Now, I'm going to rewrite this. A equals the inverse sine of 2/7 means the sine of A is 2 over 7. Now, what I'm going to do is draw a right triangle. Here's the angle A. So you're told that the sine is 2 over 7. Well, the sine is opposite over hypotenuse. I need this side. Well, by the Pythagorean theorem, what's it going to be? It's going to be 7 squared minus 2 squared. So that's 49. That's 4. So that's 45. So this side is going to be the square root of 45, which is 3 square root of 5. So here's a right triangle. The sides are 2, 3 square root of 5, right? 9 times 5, the square root of 9 is 3, and 7. So now what's the tangent? Well, the tangent is opposite over the hypotenuse. I'm sorry, opposite over the side adjacent. And then if we rationalize this, we get 2 square root of 5 over 15. Those are fun. And I'm gonna do each one of these the same way. Each one the same way. So let's do this. Let's do number 11 right here. Okay, do number 11 right here. So I'm going to let A equal what's in the argument. So A is equal to the cosine of x over 3. Inverse cosine of x over 3. That means then that the cosine of A is equal to x over 3. Well, what does that mean by definition? What's the definition of cosine? Here's the A angle. That's angle A. The definition of cosine is adjacent over hypotenuse. Now that means this side has to be the hypotenuse squared minus that side squared. Now look at the problem. As soon as I let A equal this, then my job is to find the sine of A. Well, look at your triangle. The sine is going to be the side opposite over the hypotenuse. Once you see these, once you see how these are done, they're just a hoot to do. They're fun. I'm going to let A equal this. So I'm going to let A equal inverse tangent of x. That means then that the tangent of A equals x. And remember, it's x over 1. Draw a triangle. Here's my angle. Now, by definition, the tangent is opposite over adjacent. So then this is going to be the square root of x squared plus 1, just a Pythagorean theorem. This squared plus this squared goes there. So now, as soon as I let A equal this, then my job is to find the cosine of A. And look, it's very easy. The cosine is the side adjacent over the hypotenuse. Okay? Pretty cool. So let's see, is there anything else? Okay, well, here's another worksheet. Let's do a few of these. Let's do a few of these. Not going to do them all. Not going to do them all. Maybe, I don't know, which one do you want to do? So let's do number 2. We've got a 50-foot tower located on the edge of a river. Okay, so here's my river. That's how wide the river is. And I've got a 50-foot tower. The angle of elevation between the opposite bank on the tower is 45. So we're told that this is 45 degrees. Find the width of the river. There it is. Well, now, in my picture, I've got an angle, I've got the side opposite, and I want the side adjacent. That means tangent. So the tangent of 45 degrees is going to be equal to 50 over W. But look, what's the tangent of 45? Well, that's 1. So therefore, W had better be 50. Piece of cake. Now let's do number 3 real quick. We're told, let's go over here. We're told it's a quadrant 3 angle. Now I'm going to use the reference angle. I'm going to use this angle. That's the reference angle. We're told that the cosecant is minus 4 over 11. So the cosecant is minus 11 over 4. I think I said that backwards. The cosecant's minus 11 over 4. That means the sine of t is negative 4 over 11. So this is going to be negative 4 with a hypotenuse of 11. I need to find this missing side. So let's just put a question mark temporarily. I know that the question mark squared plus a negative 4 squared has got to equal 11 squared. So I'll get the question mark squared plus 16 is equal to 121. So that means then that the question mark squared is equal to 105. Now, 105 is there a perfect square hiding in 105? Well, 5 and 1, 6, so it's divisible by 3. Let's see, 105, that'll be 3. 35, no, so that's good. 105, we can't do any better than that. So that means this missing side, I erase that, this missing side is the square root of 105. And guess what? It's negative because it's in quadrant 3. Both are negative. Find all the other trig functions. Well, we've got cosecant and we've got sine. So what's cosine? Cosine is going to be the adjacent, the square root of 105 over 11. Okay. The tangent's going to be opposite over adjacent. So that's going to be a positive 4 divided by the square root of 105. And I'm not going to rationalize that. I'm going to leave it like that. And then the cotangent, you can rationalize it. The cotangent will be the reciprocal of this. So 1, 2, 3, 4, 5. Which one am I missing? Oh, secant. The secant. The secant's going to be the reciprocal of cosine, so it's going to be minus 11 over square root of 105. And you can rationalize that if you want to. Okay? I would bet money you're going to have one like that on the test. Count on it. Now, number 4, you're told you're in quadrant 4. Okay, you're in quadrant 4. Now, down in quadrant 4, you have plus and minus. So that means the cosine is plus and the sine is minus. You want to write cotangent in terms of cosine. Well, cotangent is equal to cosine theta over sine theta. So that means we want to replace the sine with the cosine. Well, we do know that sine squared theta plus cosine squared theta is 1. So sine squared theta is 1 minus cosine squared theta. So sine theta is plus or minus the square root of 1 minus cosine squared theta. Now, which is it? Which is it, plus or minus? Well, remember, sines are y values, and these y values are negative. So that means this is going to be cosine theta, and then downstairs we're going to have the square root of 1 minus cosine squared theta, right? But remember, the y's are negative, so that's going to be a minus there. Okay? This really is your main weapon in a problem like that. Okay, let's see what else we got here. All right, we have some more of these. Fine, I can do these all day long. Remember what I'm going to do? I'm going to let A equal this. I'm going to let A equal the inverse sine of 7 over 11. Then if we rewrite this, that means that the sine of A is equal to 7 over 11. Cool? Now, draw a triangle. Draw a right triangle. Here's my angle A. The sine is 7 over 11, so this is 7, and that's 11. So what's this going to be? This is going to be the square root of 121 minus 49. Oh, well, what is that? What's 121 minus 49? Oh, my goodness. 72. I'm gonna have to do that. What's 121 minus 49? Oh, let's see if I can do that. 2. How about that? 72. Now 72 is 36 times 2. So this side is equal to 6 square root of 2, right? I've really got this. I'm going to have to calculate the square root of 72, which is the square root of 36 times 2. So that's 6 square root of 2. Now, as soon as I let A equal this, the original problem becomes the cosine of A. And just look at it. The cosine is going to be the adjacent 6 times the square root of 2 over 11. So much fun. So much fun. Let's do C. I'm going to let A equal inverse cotangent of 7 over 6. And as soon as I do that, this becomes the cosecant of A. Cosecant of A. Can't spell. CSC, cosecant of A. Well, now this means that the cotangent of A is equal to 7 over 6. So draw a little triangle. Here's the angle A, and the cotangent is 7 over 6. So this is 7, and this is 6. So this is going to be the square root of 49 plus 36. And that's 85. So this is the square root of 85, and I don't believe there's a perfect square in there. So we want to find the cosecant of A. Well, the sine of A would be 6 over the square root. The sine is opposite over hypotenuse, so the sine would be 6 over the square root. So the cosecant's the reciprocal, so this is the square root of 85 over 6. Now these, I'm going to do exactly the same way, except we don't have numbers, we have x's. So let's do C. I'm going to let A equal inverse cosine of 7 over x. Rewriting this, that means that the cosine of A is equal to 7 over x. Well, now draw yourself a right triangle. Here's the angle A. The cosine of A, it says, is 7 over x. So this is 7, and this is x. So this is going to be the square root of the big number minus the squared of the little one. Now, as soon as I let A equal this, this becomes then the sine of A. And the sine of A would be the square root of x squared minus 49 over x. Nothing to it. Nothing to it. And, well, look at what we've got here. We want to compute the area of this piece here. Okay, we're going to need two things. First is the formula for the area of a sector of a circle. Okay, now what's that? Okay, here's a circle. Here's the radius. The area of this piece is going to be equal to 1/2 r squared theta, where theta is the measure of the angle. So look, I'm going to do this. Let me draw my picture here. Here's what we're given. I'm given this is 10. Now let's investigate this. This is 10. That means this has to be 10, doesn't it? This has to be 10. Now, that means this is an isosceles triangle. That means these angles have to be the same. And then remember that they've got to add up to 180 degrees. So that means all the angles are 60 degrees. Now, for me to use this formula over here, theta's got to be in radians. Well, we know that 60 degrees is pi over 3 radians. So this whole area, that whole piece there, that area is going to be 1/2 10 squared, that's r, times pi over 3. So that's going to be 50 pi over 3. Okay? Now that would be the area of all of this. So now what I want to do is subtract out the area of this triangle. I want to subtract out the area of this triangle. Well, now we've got an issue, don't we? Because I know that this is 10, and I know that this is 10. But now let's think hard. If this is 10 and this is 10, and these angles are all the same, see, these two angles must be the same, but they've got to add up to 180, so call this angle x. Well, this is angle x, so you would have 2x plus 60 is equal to 180. So 2x would equal 120, so x has to be 60. So all the angles are 60. Well, if all the angles are 60, that means it's equal angular, and that also means it's equilateral. So this piece has to be 60. I'm sorry, this piece has to be 10 centimeters also. So each side is an equilateral triangle. Each side is 10 centimeters. So let's draw that. I'm going to turn it around a little bit. I've got an equilateral triangle. Each side is 10 centimeters. So look what I'm going to do. I need that height, don't I? The area is going to be 1/2 the base times this height, right? Well, since it is equilateral, I know that this is 5. So this is 5. This is 10. What's h going to be? H is going to be 10 squared, which is 100, minus 5 squared, which is 25. So h is going to be, actually, h squared. H squared is going to be 75. So h is going to be 5 square root of 3. So then the area is going to be 1/2. The base is 10. The height is 5 square root of 3. So this little chunk out here, the area of the chunk, is going to be the area of the whole thing minus what? 25 square root of 3. So that's what its area is. Now, it's not a pretty number, but nevertheless, that's the answer. Okay, good.